Deep in West Antarctica lies the Thwaites Glacier. So massive and unstable, it's been dubbed the Doomsday Glacier. This glacier, the size of Florida, acts as a plug holding back the West Antarctic ice sheet. But the plug is slipping. Thwaites is melting fast, losing 80 cubic kilometers of ice each year, 6 times more than in the 1990s. The real threat comes from warm ocean currents sneaking beneath the glacier, eroding its base and accelerating its retreat. As the glacier thins and retreats, even more warm water rushes in, creating a runaway feedback loop. If Thwaites collapses, it could raise global sea levels by 0.5 meters, enough to flood cities worldwide. Worse, its collapse could destabilize the entire West Antarctic ice sheet, leading to several meters of sea level rise over centuries. The fate of millions living in coastal cities could hinge on what happens here. The clock is ticking. Why does a melting glacier in Antarctica threaten cities like New York or Venice? Unlike sea ice, glaciers like Thwaites sit on land. When they melt, they add new water to the ocean, raising sea levels. Antarctica holds 90% of the world's ice, and Thwaites sits on bedrock below sea level, making it especially vulnerable. As the glacier retreats, it exposes deeper ice to warm water, speeding up the melt. Even conservative models predict Antarctica will add 10 centimeters to sea levels by 2100, but if Thwaites collapses, that number could soar. Just 20-50 centimeters of extra water by 2100 would make storm surges and flooding far more destructive. This isn't a distant threat. Coastal flooding is already happening, fueled by rising seas and warming oceans. Over 90% of the heat trapped by greenhouse gases is absorbed by the oceans, which now attack glaciers from below. Thwaites is the front line in this battle between a warming planet and its frozen defenses. The outcome will shape our coastlines for generations. With Thwaites in crisis, some scientists are proposing radical solutions: glacial geoengineering. The idea? Use massive engineering projects to slow the glacier's collapse and buy time. 2 main concepts are being explored: blocking warm ocean water from reaching the glacier's base, and increasing friction beneath the ice to slow its slide. These are not small fixes. They'd be among the largest construction efforts in history, in one of Earth's harshest environments. Supporters argue that the risks of inaction are too great to ignore, while critics warn of unknown consequences. Once dismissed as science fiction, these ideas are now being seriously studied, with small-scale tests on the horizon. The conversation has shifted from "should we" to "can we," and what happens if we do. It's a bold new frontier for climate science. One leading proposal is to build a giant underwater sea curtain on the seafloor in front of Thwaites. The goal: block the warm, salty, circumpolar deep water that melts the glacier from below. This curtain would stretch up to 100 kilometers, anchored to the seafloor and tall enough to block deep currents while letting surface water flow. It must be flexible to survive iceberg collisions and harsh Antarctic conditions. The logistics are staggering. Just getting materials to the site is a massive challenge, and costs could reach $80 billion. But compared to the trillions in potential flood damage, some say it's worth it. Researchers are exploring eco-friendly materials, like plant fiber nets that could become new marine habitats. Small-scale tests in more accessible locations are planned before any Antarctic deployment. Another idea targets the glacier's base, by increasing friction to slow its movement. Glaciers slide over bedrock, lubricated by meltwater beneath them. The plan: drill deep holes, pump out some of this water, and let the glacier stick to the rock, slowing its flow. Nature has done this before. A nearby glacier stopped moving when its base froze. Scientists would drill up to 100 boreholes through a kilometer of ice, using wind or diesel-powered pumps. This approach could be cheaper and more targeted than a sea curtain. Field tests are planned in Alaska to see if pumping out water really works. The idea has even inspired science fiction, but now it's moving toward reality. Geoengineering Antarctica is controversial. Supporters see it as a necessary emergency brake, given the catastrophic risks of inaction. Critics warn it could distract from cutting carbon emissions and might cause unforeseen environmental harm. There are also legal and political hurdles. Antarctica is governed by international treaty, and any intervention could spark disputes. Who decides to act? Who's responsible if things go wrong? The core question, is it riskier to intervene or to let Thwaites collapse? For now, small-scale tests will help us understand the real risks and possibilities. The fate of our coastlines may depend on what we learn. These bold engineering ideas are not a cure. They're a last resort. Even if we slow Thwaites' collapse, we're only buying time unless we tackle the root cause greenhouse gas emissions. Think of geoengineering as a fire extinguisher. It helps, but doesn't stop the fire if we keep adding fuel. The only real solution is a rapid global shift to clean energy and sustainable living. Glacial engineering might prevent disaster while we act, but it's not a substitute for cutting emissions. The challenge is enormous, but it's the only path to a stable future. Can we engineer glaciers to save our cities? Maybe, but the real question is, can we change our ways to save the planet? These audacious ideas show our ingenuity and our desperation. Let's hope we choose to treat the disease, not just the symptom.